Hello everyone, welcome to this channel. My name is Ruben and today we are going to talk about the big ideas from ARK from 2021. This series will basically consist of 15 parts and this one will be about deep learning. Well, this is part 1. Deep learning could be the best important software breakthrough of all time. What did they say? Until recently, humans programmed all the software themselves, and deep learning, that's a form of artificial intelligence, AI, uses data to write this software. By automating the creation of software, deep learning could turbocharge every industry. Well, according to ARK's research, deep learning will add about 30 trillion to the global equity market capitalization during the next 15 to 20 years. They basically argue that deep learning is software 2.0. On the x-axis you have time and on the y-axis you have software capability. And the graph is divided in software 1.0 and software 2.0. In the 1970s, commercial software began with the founding of Microsoft, Oracle and SAP. In the 80s, object-oriented programming made software reusable and increased its scale and capability dramatically. Then we moved to 2000, and in 2000, the internet democratized software, growing the market from millions to billions. In 2012, deep neural networks won the ImageNet challenge, marking the beginning of the deep learning software 2.0 era. And then you have this dotted line, vertical line, 2015, then we are moving more to software 2.0, and that is code written by data. And during the next decade, ARK believes that the most important software will be created by deep learning, enabling driving cars, accelerating drug discovery, and more. Deep learning is creating the next generation of computing platforms. They divide it into 3 things. The first one is conversational computers. You can think about Alexa. So powered AI, smart speakers, they answered 100 billion voice commands in 2020, and that's 75% more than in 2019. Then you have this self-driving cars. Waymo's autonomous vehicles have collected more than 20 million real-world driving miles across 25 cities, including San Francisco, Detroit, and Phoenix. And the last thing that they discuss is consumer apps, such as TikTok, which uses deep learning for video recommendations that really has outgrown Snapchat and Pinterest combined. Let's now have a look at a demonstration from Waymo itself.
As it drives, Waymo uses LiDAR, which sends out millions of laser beams per second, to build up a detailed picture of the world all 360 degrees around it. It also uses radar to detect how far away objects are and their speed. And high-resolution cameras detect visual information, like whether a traffic signal is red or green. It then combines all that data to understand the world around it. For example, in this fraction of a second, it knows exactly where it is on the road. It can also identify everything around it in full 360 degrees, and then predict what those things might do next. And it doesn't just do that for the objects you and I can see. It can do that for things up to 3 football fields away. What makes everything you can see right now possible is experience. Waymo has already self-driven millions of miles on complicated city streets, and it's constantly learning from every single mile it drives. With all that knowledge, it can plan a safe path ahead. In this instance, giving that cyclist enough room to cycle past us, and also looking out for that pedestrian on the sidewalk. And when it comes to making decisions, this is a good example of how Waymo doesn't just take into account your safety. It also makes sure that both you and the people around you feel secure and at ease.
Deep learning requires boundless computational power. On the x-axis we have time, and on the y-axis we have cost to train with 2020 hardware. And ARK has the following to say about this. While advances in hardware and software have been driving down AI training costs by 37% per year, the size of the AI models is growing much faster, 10 times per year. As a result, total AI training costs continue to climb. We believe that state-of-the-art AI training model costs are likely to increase 100-fold, from roughly 1 million today to more than 100 million by 2015. It's like a vertical line here, and the dotted circle shows a range of cost possibilities, with the bottom line representing the outcome if progress slows down. The latest developments have been GPT-3, Mena, Tesla Autopilot, and AlphaFold 2. Deep learning is creating a boom in AI chips. If you look at this graph, we have the total AI chip market starting in 2016 with a compound annual growth rate of 50% till 2020, and from 2021 to 2025 we have a compound annual growth rate of 33%. As AI training costs grow from 1 to 100 million per project, specialized processors such as GPUs or TPUs, they will account for a majority of the incremental growth. And ARK estimates that data center spending on AI processors will scale more than fourfold during the next 5 years. So that's growing from 5 billion a year today to 20 billion in 2025, and this upcoming deployment phase for deep learning will democratize access to AI, benefiting not only large internet companies but also every industry in this economy, because we're going to use more data. Currently, AI is expanding from vision to language. 2020 was the break year for conversational AI. For the first time, AI systems could understand and generate language with human-like accuracy. Conversational AI requires 10 times the computing resources of computer vision and should spur large investments in the coming years. So on the x-axis we have time again, year, and on the y-axis we have computing time, petaflop in days. So pre-2010 we had pre-AI. Industry penetration is most global 2,000 companies today. We move 5 years forward to 2015. We have computer vision with select technology companies and startups. Then you had this era from 2018 to 2000. AI giants like Google, Facebook, Amazon, and OpenAI. And as of 2020, we are in the phase of reinforced learning, and that's going to be the focus on research organizations. One of these technologies is called GPT-3. OpenAI's GPT-3 is the first AI that understands language. For instance, GPT-3 translates legalese into plain English. So on the left side you have like so-called complicated English, and this program is able to translate that into plain English. GPT-3 can also write emails, design web pages, write code in a dozen of computer languages, retrieve whole historical artifacts, and so forth. Here is a demo from GPT-3's technology.
You can really ask it anything. In fact, you can almost use it like a search engine where you ask it a question, it can give you one result, giving you the citation of exactly where to find that answer. So Google and Apple and Amazon have thousands of engineers working on this problem, and we're able to use this artificial intelligence to solve a very similar problem almost instantly. Just amazing what you can do with the tech. One of the common applications of GPT-3 is translation. So here we can give it an example of an English sentence that we want translated. Your order will arrive in 7 to 10 business days, and ask it to translate into French. We can also use translation to translate things that are written in legalese, this is an NDA, non-disclosure agreement, and translate that into something that a second grader would understand. Really useful.
Seizing the opportunity, deep learning could create more economic value than the internet did. Let's have a look at the graph. They make a distinction between the internet wave and the deep learning wave. The internet wave is from 1997 to 2000, with internet having a value of 13 trillion. Deep learning had a value of 2 trillion in 2020, and if you fast forward to 2037, Internet will have a value of approximately 20 trillion, and deep learning has grown exponentially to a value of 30 trillion with a compound annual growth rate of 17%. Thank you everyone for watching this video, and see you on the next part.